Welcome to Construction Math. Today we're going to learn about using trigonometric ratios. Make sure your teacher has handed out your note taker. Let's get started. Bell work. I want you to think about a time that you wanted to measure something, but for some reason couldn't touch it. So write down at least one example on your note taker. Teacher, pause the video, have the students complete this task, have them share with their partner, and then call on non-volunteers, and I'll meet you back here in a minute. Welcome back. Possible answers could be a flagpole, a mountain, how high a ladder would go up the side of a house safely, and I'm sure you got many others from the students in your class. So let's go on. The objectives today, all right? Please fill in on your note taker the words in red. First, we're going to define terminology. 2, we're going to label a right triangle with opposite, adjacent, and hypotenuse. We're going to solve for a missing side in a right triangle using trig ratios, and use trig ratios to solve applied problems. Pause the video if the students need to complete this task of filling in the missing words. Welcome back. We're going to study about trig ratios today, so I need you to be able to solve these 2 equations for your math chat. Teacher, pause the video, have the students solve these 2 problems, have them compare with their partner, and then call in non-volunteers, and I'll meet you back here in a minute or 2. All right, welcome back. Let's go to our slates and let's go ahead and see about solving these. All right, problem number 1 said 5 equals x over 4. So this says 5 equals some number divided by 4. The inverse of dividing by 4 is multiplying by 4. So what I do to one side, I do to the other. 4 times 5 is 20. Dividing by 4 and timesing by 4 are inverses. They cancel out. So there's my answer for the first problem. Pretty easy. Number 2 said to solve 10 equals 5 divided by x. Well, we've got our variable in the denominator now, so the first thing we want to do is get it out of the denominator. So the first thing I'm going to do is multiply both sides by x. So I get 10x equals, and again, dividing by x and timesing by x cancel each other off, equal to 5. The inverse of multiplying by 10 is dividing by 10. So 10 divided by 10 is 1, so I get x equals 5/10. Since we know how to simplify fractions, I get 1/2. All right, how'd you do? I hope you got them both correct. All right, pause the video if students need a chance to copy them into their notes, and I'll meet you back here in a minute. Welcome back. Let's go back to our PowerPoint. And the thing I need you to make sure you have today is make sure that you have the ability to do sine, cosine, and tangent on your calculator. In other words, I need you to have the scientific part of your calculator on your phone available. All right, so here we checked it. Got the first one right, we got the second one right, and we're off. All right, so on your note taker, you will have vocabulary squares to fill in. So sine, it's spelled S-I-N-E. It's abbreviated S-I-N, but we don't say sin in math, we say sine. It's the ratio of the length of the opposite to the length of the hypotenuse. Cosine is abbreviated COS, and it's the ratio of the length of the adjacent side to the length of the hypotenuse. And tangent is abbreviated TAN. We don't say tan or cos or sin. We say their full names. Tangent is the ratio of the length of the opposite side to the length of the hypotenuse. So let's go ahead and go to our slate, and I want to show you a little way to remember this if you haven't learned it already. All right, so in sine, sine of an angle is the opposite side over the hypotenuse. And in math, we use thetas. It's just a variable. It's there to honor the ancient Greeks. We don't usually use x's in trig functions. Cosine of theta is the adjacent over the hypotenuse. And the tangent of theta is the opposite over the adjacent. And this is how I learned it all those years ago. I learned that sine is opposite over hypotenuse, cosine is adjacent over hypotenuse, and tangent is opposite over adjacent. So we said so, ga, toa, and that helped us to remember that. If you have another way to remember that, that's great, but these 3 things, you're going to need to memorize these 3 ratios. Okay, so add those to your notes. Practice it for a second with your partner, and I'll meet you back here in a minute. Welcome back. Let's go back to our PowerPoint and let's look at a diagram. So on your note taker, I have labeled the opposite, the adjacent, and the hypotenuse, and it's always in reference to the angle stated. So I have angle theta, and so I look across the triangle, and that's the opposite side. The hypotenuse is always across from the right angle, and the adjacent side is one side that makes up the angle. So let's go ahead, fill those in. Teacher, pause the video if you need to, and then we're going to come back in a minute. Welcome back. So on your note taker, fill in the theta, and then add opposite, adjacent, and hypotenuse to the three sides. Teacher, pause the video, have the students compare with their partner, and call on non-volunteers. Welcome back. Let's go to our slate and let's look at this. Let me see if I can draw a reasonably good right triangle. And here's my right angle, and here's theta. All right, so I can look right across from the right angle, and that's always the hypotenuse. I have my indicated angle theta. I look across, and that's always the opposite side. And the missing side is going to be the adjacent. Notice it makes up half of the angle theta, and that should be our answer. So if you have any questions, pause and ask your partner or your teacher. Welcome back. Let's go to our PowerPoint and let's see exactly what I had on the slate. So that is perfect. All right, so now in construction, you're going to be using ladders often. And safe use of a ladder is important. We don't want people falling down our ladders or injuring anybody. The ratio of the distance the ladder is from the wall should be about 4:1. So about 4 feet up to every 1 foot out, or approximately 75 degrees. So would you add that to your note taker? That a safe angle for a ladder is approximately 75 degrees. So here's a construction application, right? We want to find out how long a ladder we're going to need to reach 15 feet up the building and use the safety angle as 75 degrees. So in this lesson, we're going to learn how to solve this, right? So first of all, I need to teach you about sine. Here's a triangle, and I've labeled the sides. The sides are 6 and 8, and the hypotenuse is 10. So to find the sine, I look across from the angle theta and I get a 6. The hypotenuse is 10. I simplify it and I say that my sine is 3/5. So add any missing pieces to your note taker and we'll move on to cosine. Cosine is adjacent over hypotenuse. Again, I'm using the same right triangle, and across from the right angle is 10. That's the hypotenuse. The side that helps make up the angle is 8. So here I just substitute in the adjacent side is 8, the hypotenuse is 10, and I simplify. So for this particular angle theta, the cosine is 4/5. And with tangent, tangent is opposite over adjacent. So we've already indicated that the opposite side across from theta is 6. What makes up for it is 8. So we get the tangent is 3/4. All right, pause the video if you need to and ask any questions. Remember, we always simplify fractions because we're big boys and girls. We're in high school now. So here's your U-try. Here's a lovely triangle. We have theta in the other corner now, and I want you to find sine, cosine, and tangent. All right, pause the video and have students do it and have them compare with their partners, then call on non-volunteers. Welcome back. Let's go to our slate. So I'm looking at this triangle. Boop. Here's my right angle. I'm labeling it since it doesn't really look like a right angle. Here's theta, my angle of reference. Here's 5, 13, and 12. So from this angle, I'm going to go ahead and label. Here we go, right across. This guy is the hypotenuse. Across from the angle is the opposite side, leaving me 5, which helps to make up the angle, and that's the adjacent. So let's go ahead and find it. The sine of theta is the opposite over the hypotenuse. Remember, so the opposite side is 12, the hypotenuse is 13, and that fraction doesn't reduce or simplify. Cosine of theta is the adjacent side over the hypotenuse. Adjacent is 5 over, and the hypotenuse is 13. Again, that doesn't simplify. The tangent of theta is the opposite over the adjacent. It will be 12 over 5. None of those simplified, but those are our answers. So take a second and add those to your notes and check your answers. And I'll meet you back here in a minute. Welcome back. Let's go back to our PowerPoint and check to make sure I did everything correctly. Yep, there I showed you the final answers. Nice. All right, so now we're going to use trig ratios to find a missing side. We're going to combine what we know about sine, cosine, and tangent and what we know about solving equations. So let's go to the slate and let's go back and see what my triangle looks like. All right, here, and we have 30 degrees. This time instead of theta, we have a real answer, or a real value. The hypotenuse is 3 and this side is x. So I know this is the hypotenuse because it's across from the right triangle. This side helps make up the triangle, so it's called the adjacent side. So I pick which trig function I know or want to find. So cosine of an angle is the adjacent over the hypotenuse. So here we go. The cosine of 30 degrees is going to be the adjacent is x, and the hypotenuse is 3. Make that into a 3. All right, so we want to solve for x. This is just like in the note, in the math check. It's some number divided by 3, so I'm going to multiply both sides by 3. So I get x equals 3 times the cosine of 30 degrees. Now you're going to go to your calculator. There's a couple things you need to make sure of. First thing you need to make sure of is that the mode is in degrees. Calculators have the ability to do radians and gradients, but we don't want that. Our problem has degrees, so we want to make sure that it's in degrees. All right. Then what you do in your calculator is you type in 3, a button there. You push the cosine button, and normally it'll come up with a parenthesis. You just have to hit 30 and then hit equals. And if you did it properly, let's see what we should get. You should get 2.6. We're going to round off to the nearest tenth in this assignment. So teacher, pause the video. Students, make sure that you get that same answer. If somebody needs some help, kind of help each other, because if I did a calculator in here, not all of you would have that same calculator. So pause the video and I'll meet you back here in a few minutes. Welcome back. Let's go back to our PowerPoint and let's walk it through. All right, we know adjacent and we want to find, we know the adjacent side. No, that's wrong. We know the hypotenuse and we want to find the adjacent side. So we use cosine. I will fix that on the next one. Now, here we go. I set it up properly. I solved it and got the right answer. So let's go on to the next one. We're going to find a missing side again. So I want you to add the values to your note taker, and then I want you to decide which trig function should I use. Should I use sine, cosine, or tangent? Teacher, pause the video, have the students fill in the missing values on their note taker, and then decide that. Please call on non-volunteers, and I'll meet you back here in a minute. Welcome back. We know the hypotenuse and we want to find the opposite side, so we use sine. So on your note taker, go ahead and set up the trig ratio and we'll see how we do. All right. Let's go to our slate and let's see what happens here. All right, I want to draw a right triangle. Right here, this guy is 45 degrees, this guy is 12, and this guy is x. So across, this is the opposite side. This is across from the right triangle since it's the hypotenuse. So I know it's sine because sine is opposite over hypotenuse. So the sine of 45 degrees would be x over 12. Did you set it up properly? If not, please add this and now take a minute and solve it. Teacher, pause the video, have students compare with their partners, and call on non-volunteers. Please remember to round your answer off to the nearest tenth. Welcome back. Let's see. I need to solve it for x. So the opposite of dividing by 12 is multiplying by 12. So x equals 12. I put that in my calculator. I hit sign. I should still be in degree mode. 45. And if you hit answers, it should be 1.4, which should make sense that across from 12, 12 is always going to be the biggest. The hypotenuse must be the biggest. All right. So let's go ahead and make sure you check. Meet you back here in a minute. Welcome back. Let's go back to our note taker and see. We set it up right. We got the same answer. All right, now you copy this one onto your note taker and then decide which trig function it is and set up the trig ratio. Pause the video until students have done that. Call on non-volunteers to figure out which trig function it is. Welcome back. Let's see. We know the opposite side and we want to find the adjacent side. That means we must use tangent because tangent is opposite over adjacent. So please set up the formula and then solve for that. Compare with your partners and then teacher call on non-volunteers. Welcome back. Let's go to our slate. And here we go. Here's my picture. I know you probably draw much nicer triangles than I do. All right, so here's x. This is 10 and this is 20 degrees. We decided it was the tangent of 20 degrees is equal to the opposite side over the adjacent side. Got that set up. This one's a little more difficult because again, the variable's in the denominator. So I'm going to multiply both sides by x to get the variable out of the denominator. So I get x times the tangent of 20 degrees, which is just a number, is equal to 10. I want to get the x all by itself. So the opposite or inverse of multiplying by tangent of 20 is dividing by tangent of 20. So in your calculator, again, it should still be in a degree mode. So you push in 10, the way you know how to do that, then hit divided by tangent 20 degrees. Push the tangent key, push the 20 key, and you should come out with 27.5. Double check that you got that same answer that I did. Okay, now let's go back to our PowerPoint and let's see. Here's a couple. There we go. Solved it. Now here's one for you to do. Write this on your slate and find the missing side. When the teacher calls for you to show, go ahead and show, and then teacher will decide who to call on for the answers and explanation. Pause the video until this problem is solved. Welcome back. Let's go to our slate and come in, and we can come here. Here's my triangle. This was 50 degrees. This is my right angle. The hypotenuse was x, and the opposite side was 12. So let's set it up. The sine of 50 degrees would be equal to 12 over x. Again, the variable's in the denominator, so multiply both sides by x. So I get x sine of 50 equals 12. Divide both sides by the sine of 50. So I get x equals 12. Punch that into your calculator, divided by, push the sine button, and then push in 50, hit equals, and I came out with 31.3. And that makes sense because the hypotenuse needs to be bigger than 12. So teacher, pause the video until students have had a chance to check this, and I'll meet you back here in a minute. Welcome back. Let's go back to our PowerPoint and see. Here we got it set up, and it's exactly the same answer. It's just worked out and shown with a little bit nicer triangle. Now we're going to go back to that construction problem that we had at the beginning of this PowerPoint and presentation. How long is this ladder going to be needed to reach up 75 feet up the building? And we're going to always use the safety angle of 75 degrees. So we're going to first of all have you draw a picture and label it. So this time I'm going to have you work with your partner to draw a diagram of this picture that's needed for this picture and label it. Okay. Pause the video and I'll meet you back here in a minute. Welcome back. Let's go to our slate and let's see what happens. Here is the side of the building. Here's my ladder. The right angle's always going to be up against the building. Here's the ladder right here, and let's fill in what we know. The safety angle is 75 degrees. That's the degrees that the ladder makes with the ground. And I want to find out how long the ladder is if I need it to reach up 15 feet up the building. So there's my diagram. So now from here, here's the right angle. So this is the hypotenuse. This side is across from the right angle, so it's the opposite. So that's going to be the sine. So the sine of 75 degrees has to equal the opposite over the hypotenuse. Again, now solve this problem. Teacher, pause the video until they've gotten a chance to solve. Welcome back. Let's solve it. Again, the variable's in the denominator, so I'm going to multiply both sides by x. So x times the sine of 75 degrees equals 15. To get x by itself, divide both sides by the sine of 75 degrees. Round it to the nearest tenth, and I got 15.5. And since this was a real life problem, I need to label my answer, and it was in feet. All right, pause the video and check your answer, and I'll meet you back here in a minute. Welcome back. Let's go back to our PowerPoint, and let's see. There's my diagram. I use sine because we know opposite and want to find the hypotenuse. I set it up and I got the exact same answer. Looking good there. All right. Last thing to do today is closure. I want you to tell me 3 important terms that you learned today or that we used in this lesson, 2 ideas or facts you'd like to know more about, and 1 skill or concept that you have mastered. Teacher, when you've turned off the video, have the students share their closure with their partners and call on non-volunteers. And I'll meet you back here another day for another construction math.